Well, hello everyone, and welcome to Empowering Users with Natural Language Search. My name is Sherry Moran. I'm a Principal Solutions Architect for AWS, and I'm thrilled to be co-presenting today with Raman Beheshti, Chief Product and Technology Officer at Dow Jones. So in this session, we're going to be focusing on the power of natural language search to really transform the enterprise search experience to one that's more intuitive, more intelligent, and more productive for your users. So reimagining enterprise search with AI services really opens the door to new and exciting possibilities that really weren't there with conventional search tools. So it is our goal to share these possibilities with you today. So let's get started. As far as a quick look at our agenda, first I will be discussing the challenges of enterprise search today, followed by a brief overview of Amazon Kendra, our fully managed intelligent search service that is powered by ML, and how specifically Kendra addresses these challenges. Then Ram is going to come in and lead a discussion on how the Wall Street Journal used natural language search to power their new and innovative tool called Talk 2020. And then finally, we'll close with a call to action. So what is the challenge with enterprise search today, and why is it still so frustrating and difficult? Well, as it turns out, even after all of these years with enterprise trying different search tools, employees still spend 20% of their time looking for information. And 44% of that time, they cannot find the information they need to do their job. So clearly, it's not a great success story. So why is that? What is exactly are these key challenges? So AWS talked to many of our customers across various verticals and even sizes of organizations, from small startups to large global enterprises. And we've been able to consistently identify two key challenges. The first is low accuracy, and the second is complexity. So in terms of low accuracy, it really boils down to the fact that 80% of the data in the enterprise today is unstructured, and it's growing exponentially every year. So if you think about the content that people are searching today, it's wikis, it's web pages, blogs, product documentation, policy documents, everything's a narrative today. But to find a precise answer in that ocean of unstructured data, it's very difficult to do. The low accuracy problem is actually mainly due to a mismatch between the tools that are being used for search and the nature of the content that's being searched. Now, the other key contributing factor to low accuracy are keyword engines. So without a doubt, keyword engines are very prominent in the enterprise today. However, again, they're just not fit to find precise answers in unstructured data. So just as their name implies, they're great for keyword searches. But unfortunately, keywords lack context. So inevitably, what happens when you get back your search results, it's just a list of documents, many of them unrelated to what you're looking for. So overall, it's not a very good user experience. So the second key challenge involves complexity. And what we mean by that is complexity in setting up search applications for enterprise data. Companies today still have scattered data silos across their enterprises. They have vast amount of text and all different types of formats, and it's spread across disjointed data sources from on-prem and in the cloud. So pulling all of that information together into a single search index is very difficult to do. And once you set it up, then you have this extensive manual maintenance, for example, tuning for relevance as the information in the enterprise changes. So overall, complex to set up, to maintain, and to aggregate all of that data into a single search index. So after further research and analysis, AWS saw this as a great opportunity to fix the enterprise search problem for our customers. But we took a unique approach by looking at the problem from an ML point of view. And as a result, we built and launched Amazon Kendra, a highly accurate and easy to use intelligent search service that's powered by machine learning. It allows you to intuitively search that unstructured data that we were just talking about using natural language search. So it's almost as if you're sitting across from a human expert. So it understands the context of your queries and it provides you that better result. So it really is a game changer in terms of the enterprise search experience. So to better understand where Amazon Kendra fits in terms of the overall AWS offering for ML services, let's take a quick look at the AWS ML Stack. So at the bottom layer is the frameworks and infrastructure layer. And this layer is really geared for those expert ML practitioners that really feel comfortable building and maintaining their own ML platforms and underlying infrastructure. So this is where you'll see things like TensorFlow, MXNet, PyTorch, for that matter. Now, the middle layer is the ML services layer. And this layer is really geared towards those ML developers and data scientists that want to build, train, and deploy their own ML models. And this is where you see things like Amazon SageMaker and Amazon SageMaker Visual IDE to help you with that journey. Now, at the top layer is the AI services layer. And that's geared for developers to use pre-trained and auto-trained models so that they can add intelligence to any application and they don't even need ML expertise. So it's this higher level of abstraction where you find Amazon Kendra. And the benefit to you as a customer is that you can add this solution-oriented intelligence, such as search, into your application via API calls and not have to build and train your own ML models using SageMaker. So now that we know what Kendra is, how exactly does Kendra help you quickly and easily find information? Well, to put things in perspective, on the left-hand side, I've identified the 4 core components of Kendra that really addresses that low accuracy problem we talked about earlier. And it makes it easy for you to find information. There are natural language queries, NLU, and a machine learning core, domain expertise, and continuous improvement. And we'll talk more about them in a couple of minutes. And on the right-hand side, we've identified the 2 core components of Kendra that deal with the complexity problem. They make it simple and quick to set up. Native connectors and a simple API and console experience. So let's dig a little deeper. So starting with natural language queries. So Kendra's ability to understand natural language queries and questions is really at the core of its search engine. So it allows users to ask questions intuitively and more precisely so that you can get back that precise answer from the search engine. So rather than typing a bunch of awkward keywords, you simply ask the question. The second core component is NLU and machine learning core. So in order to really support natural language understanding, we had to build a new engine from the start with state-of-the-art natural language understanding in order to really understand the nuances of language that are present in your user query and text in order to find those precise answers. So when we built Kendra, we found out very quickly that there is not one single machine learning model that will always give the best answer every time because content varies. So Kendra is actually a bundle of 3 different ML models that work in parallel to give you back those best answers. So let's talk about those. The first one is reading comprehension. And reading comprehension really understands concepts in text. So they understand what a person is, an organization, a location, a quantity, just to name a few. And reading comprehension can then extract an answer based on the semantic meaning of your query. So it's this model that really focuses on that needle in the haystack. And what I mean by that is it finds that exact word, that exact phrase, or that exact paragraph that answers your specific questions. So this is what's being supplied by the reading comprehension machine learning model. That is your needle in the haystack, your precise answer that you're looking for. The second ML model is FAQ matching. So Kendra makes it very easy for you to load up FAQ documents that have curated answers and questions. And what the FAQ matching model will do, it will match your query with the best matching question so that it can provide you the exact answer. So in that case, you don't have to go searching through a bunch of FAQ documents to find your answer. Kendra does that for you. And then the third machine learning model is document ranking. And with document ranking, we're actually returning you, it's based on our support of deep learning semantic models, and it's returning you a list of relevant documents based on the meaning of your query. So this is kind of similar to traditional search results where you get back a list of documents, but there's a key difference. Because Kendra is context aware, the relevancy of the returned documents is significantly higher because it's contextually aware. So it is the combination of these three ML models working together that really provides that powerful and rich user experience from Kendra. And the third component is domain expertise. So in order for Kendra to understand your user queries and text even better, we have pre-trained Kendra's models across a number of domains that can really associate domain-specific terminology with your user query to make sure we're giving you the best answer. So we've optimized today, Kendra, across 14 major domains. M&E is one of those domains, and it just allows Kendra to be even more familiar with industry jargon and context as it relates to a wide range of industries. And continuous improvement is the fourth core component. So with continuous improvement, we're focusing on making sure that Kendra improves its accuracy over time and keeps up to date by observing search behavior and learning from user feedback. So that's the beauty of having ML for search. You always have that opportunity to retrain those models whenever, on a regular basis, whenever the information in the enterprise changes. So coming soon, Kendra will be able to capture these signals from things like click-throughs and user feedback and periodically and automatically retrain those models. And it's all transparent to you. No action required on your part. So the more you use Kendra, the more accurate it becomes. And the final feature I wanted to highlight is an optional one, but it's a really important one. And that's something called relevance tuning. So Kendra gives our customers the power to be able to tune and boost for relevancy in the search results. So for example, you might want to boost whether a particular data source is more authoritative over others, because that's important to your business, right? So there's a couple of options in this regard, but stay tuned. This is something that you'll hear a lot more in Raman's presentation.
Thank you so much, Sherry. Now, Sherry talked about the way that Kendra is kind of used to solve the enterprise search use case. At Wall Street Journal and Dow Jones, we actually took Kendra one step further and made it available to all of our external customers and readers of the Wall Street Journal. And I'm going to talk a little bit about that. Now, just as a bit of context, the Wall Street Journal is part of an overall company called Dow Jones. We have three different businesses there. Obviously, the Wall Street Journal, another B2C offering in Barron's, and a B2B offering which has a repository of 1 billion premium news articles that we sell to other companies through something called Factiva. And that's going to become relevant as we go through this presentation, because as we looked forward to the US elections at the start of 2020, this was a huge event for the United States and a huge event for a news company like the Wall Street Journal. And we wanted to do something that really kind of helped us connect the audience with our mission statement, which is to help people find the truth in order to be able to make decisions. We really wanted to build a product that allowed people to be able to find that, and also to utilize kind of the latest technology and all of the services that Dow Jones has. And that's why we ended up building Talk 2020, which was using our Factiva repository of content, using Kendra to make it really easy and intuitive to search, that allowed our customers to be able to ask questions and get answers about what a candidate has said about any topic that was kind of pertinent to the elections, and what they'd said in the past and what they were saying kind of almost in the moment. And that's what I'm going to talk about in terms of this customer spotlight. So how did this kind of begin? How did Talk 2020 come to life? Actually, Talk 2020 had its origins in the fact that we built something quite quickly for our internal uh, Washington bureau. So our political reporters in DC wanted a way of being able to very, very quickly look at the information that we had in Factiva, pull out relevant insights that would help them then generate kind of news articles for the Wall Street Journal. So we built this tool. You can see it on the screen now that, not particularly UI friendly, that was very, very much designed for those kind of people, those kind of 10 or 15 people in our Washington, D.C. bureau that were going to be covering the elections. And what we realized was actually this is a fantastic tool that we could, with the right technology, make available to our members and to our customers, to the masses, right? And that posed, as I said, some kind of significant challenges in terms of, first of all, did it meet a user's need? And I think we got quite clear once we built it internally. We thought, actually, you know what, this is something that's going to add real value to our members, and it sits right in the sweet spot of our kind of mission statement. But what we had to kind of rethink almost from the ground up was, our Washington D.C. bureau knew exactly what they were going to be looking for, and so the tool that we built internally was fine. But actually, when you've got a much more casual user experience, people who might not have immersed themselves in the candidates' policies, who might not know exactly what they're looking for. And so we really had to kind of think about this kind of search versus browse, right? So if you know what you're searching for, you know the type of thing that you're searching for, you could search for it. But if you just wanted to see what the candidates were saying on a topic, we also kind of gave this browse capability. We also really wanted to make it kind of valuable in the sense of being able to share. So what we found when we did the kind of customer research before we started to build the customer-facing Talk 2020 was people wanted to use these kind of quotes, things that the candidates had said, to send to their colleagues, to send to their friends, to kind of help put their point of view across about that particular candidate. So sharing became a really, really important thing. One of the other things, obviously, we have a membership base in the millions, and we have kind of tens of millions of people visit the Wall Street Journal, and so we needed to make sure that this solution was scalable. And then the final part was, while we wanted this to be a very standalone experience, we also wanted it to connect back to the rest of the Wall Street Journal user universe. So we wanted to make sure that if you were kind of searching for something that a candidate had said, if there was a relevant article or a relevant news piece, we were able to kind of bring you back into the rest of the Wall Street Journal content. So that was the challenge. It's one of these things that it's much easier if you can see it for yourself rather than have me describe it to you. So I'm going to hand over to one of my colleagues now who's doing a short demo. But if you wanted to, after this recording, you could go to wsj.com/talk2020 and experience it for yourself. So I'm going to hand over to Tyler, who's going to do a very quick demo that takes you through it.
So here at the top of the application, we have the ability to ask the application a question. And then down here, we have our dynamic lists of candidates or issues that people can use to navigate. But let's just go ahead and ask Talk 2020 a question. So we can say, what has Biden said about China? And the application will return to us what it deems to be the most relevant quotes that Joe Biden has said, with, of course, boostings for things like recency. But this is sort of what the application deems to be the most relevant. You can continue to filter by date or by other issues. So this is, show me things he said about China, but also economic things he said about China. You can click through and see more info about the quote. So this would let you go to Joe Biden or more on foreign policy, and then more things from the journal. Down here, we have the ability for the users to give us feedback on these results. We wanted to keep a really high touch, sort of a manual application to the result set. So we weren't just tweaking relevancy automatically, but we were allowing people to give that feedback so that we can go back and tweak when we saw trends and stuff like that. If you wanted to continue on, you could then click to read the full transcript. and see the original quote within the context that it was originally uttered.
Thanks, Tyler. And hopefully you got a sense now of what the customer experience we built for Talk 2020 was. Now, as this is an AWS presentation, let's go into the architecture. And it wouldn't be an AWS presentation, quite frankly, if we didn't have one of these cool architecture slides. And it was quite a complex architecture, so I'll break it down into a number of different parts. I guess the first bit was the feed from Factiva, right? So as I mentioned, all of the content that we used that was kind of searchable on the Wall Street Journal was coming from this, huge repository of news sources that we have in Factiva. And so the first thing that we needed to build was build a real-time ingestion pipeline from Factiva to Talk 2020 that allowed the flow of information to become available. And as part of that, we built an ETL pipeline, and using AWS's SageMaker, we use that. So while Factiva is a very highly structured data repository of this news content, what it doesn't do is it doesn't kind of give structure to a transcript or to an interview. And so we needed and used SageMaker to enrich some of the content that was coming in via Factiva, and that will become important as we go into the kind of search and browse features. And then obviously we had Amazon Kendra in the middle, and that sat on top of a DynamoDB instance, or a series of DynamoDB instances that kept and the way that we architected this became quite important as we went through it, that kept a breakdown and a configurable list of candidates, topics as well. So that as the election kind of changed, and we actually started this in the end of the primaries, as the election kind of changed and adjusted, we could add or remove candidates or add or remove other topics. So for example, when there became a vice presidential debate, we were able to add in the two vice presidential nominees, and people were able to kind of search on what they had said on those particular topics as well. And that was really an important part of the architecture. And then we used caching to make sure that the tool was as performant as possible. We would typically keep searches kind of cached for approximately an hour, but obviously, the news cycle was never static, and so we needed to continually make sure that the repository was updated. That's why the real-time pipeline was important, but it was also really important when it came to the trade-off between our kind of caching in terms of performance versus kind of up-to-date information and up-to-date kind of quotes. And then finally, we broke down each of the services into separate APIs that was available then on the front end. So whether you were kind of searching by a topic or by a candidate or drilling into a transcript, we created separate API calls for each one of those, and that obviously connected to the kind of wider Wall Street Journal tech stack. So that's a little bit about the overall architecture. Kendra really kind of came into its own for all of the reasons that Sherry kind of talked about. Out of the box, it gave so much in terms of kind of context, in terms of configurability. So we were able to kind of tweak the search results, and I'll talk a little bit about that. It gave us kind of quite a lot of scalability, and it really kind of helped accelerate and make much more relevant the information that we were kind of able to provide to customers. And that was key from turning it in from an internal tool to making it externally available. Because like I said, people were going to be asking, different types of questions. They weren't going to be as informed. And so we needed a technology solution that out of the box gave people kind of relevant answers. And then what was great about Kendra, and like I said, Sherry kind of alluded to it, was the ability to kind of boost. So actually out of the box, we got what we would have said was okay in terms of, or good in terms of its kind of search results, but the boost really allowed us to kind of tweak the search results and deliver kind of more value to customers, and that's one of the powers of that we found of Kendra. So what did we actually boost on? So an example here that we were able to kind of configure Kendra and make the results much more kind of relevant was full quotes, right? So you can see on the snippet on the right, this is an example of the debates, and you can see that Trump has referenced Obama. And, it's not a particularly useful quote. So if you're searching for what has Trump said on Obama, this doesn't really tell you a huge amount. And so what we were able to do was actually get Kendra to boost the results of full quotes rather than kind of partial excerpts. And as you saw in the first presidential debate, I think between Biden and Trump, there was a lot of these type of kind of transcripts that made their way in. And so we were able to kind of to make sure that the relevancy was kind of tweaked such that actually full quotes were kind of pulled back rather than kind of snippets of statements. So that was one boost. The second boost that we did was that because we were pulling from this huge corpus of content from Factiva, there was often a library of transcripts from different media sources, and they would actually replay the same set of quotes. And so what we were able to do was to boost based on recency, and also at the same time be able to boost based on the original source, right? So we always wanted to pull back the most original piece of information, where it's kind of referenced first, but also make sure it's the most recent. And so those two things kind of played hand in hand, and that was hugely important at kind of deduping a lot of repetition that when somebody searched. And so in the search results, we were able to kind of pull back, like I said, the most recent and the most original source for that particular quote related to the topic. And then the final part was around making sure that we had quality in our returns as well. So it was all well and good returning multitude of search results, but we wanted to make sure that the ones that appeared higher had a higher percentage of the candidates' quotes, right? So i.e. if a transcript had, or a media appearance or a media write-up had one quote versus another one that had the same quote, was more recent and had 10 different other quotes from the candidate, we would be able to prioritize that one over the first one. And that again helped make sure that the results were much more relevant and engaging to the end customer. I mentioned a little bit the Factiva is very structured in what it provided, but that we had to use SageMaker to add on top of it our own kind of taxonomy, especially when it came to these kind of transcripts. And that was a huge part of this, especially when it focused on browsing by topic. So what we were able to do again was to use SageMaker and to put in on top additional kind of granularity over some of these quotes, over elements of the transcripts, and that enabled us to build the browsing that you saw by kind of topics. And we used and worked really closely with AWS's data teams to be able to kind of train that part to make it much more useful for the end customer. So what happened? Was it a success? We think so. We launched it we launched it in anger in September, and it was ready for the first debate between Trump and Biden. And as you can see, the usage kind of came really around those debates, whether it was the vice presidential debate, the town halls, or the two presidential debates. And we'd like to think if there was a third presidential debate, the tool would have got kind of even more usage. But people really gravitated towards it around those kind of key moments in the election. And we saw kind of, nearly 500,000 page views. We saw kind of tens of thousands of different types of queries that were performed, some many different times. During the debates, we saw that it was used as a second screen. So especially in the second debate, it was used as a second screen experience. If Biden was saying something on stage, people were kind of checking back as to what has he said about that in the past. In the first presidential debate, if you see that kind of big spike, what actually happened was people came in the next day to try and make sense of, it was obviously quite a confused debate, and people came in the next day to try and make sense of what were the candidates' thoughts on a particular topic. So, if Trump had referenced something the day before, people came in the day after and kind of saw what else Trump had been saying, which was really, really interesting. And so what we saw was actually on the day of the debate or during the debate, people kind of typically did one or two searches, but the day after they went much deeper. They browsed. They kind of went from one search to a second search to a third search. They went back to the Wall Street Journal, read articles, and the level of engagement the day after the debate was really, really significant. And overall, it was a really powerful experience that we built that got a lot of great feedback, not only from our existing members, but also from potential subscribers to the Wall Street Journal as well. So what was interesting is I kind of alluded to this concept of search versus browse, and we knew that people needed to or would potentially, some people would need help. And actually what was really interesting was the split was about 70-30 in terms of kind of search versus browse, and that was also by design, right? We wanted to give people the option to be able to browse by candidate or be able to browse by topic, but really search was kind of prominent and at front and center, if you like, of the UI and of the design. So it's good that people kind of use that natural ability and that natural language that Kendra provides to be able to ask questions. And as I said, they performed kind of tens of thousands of different searches. Sometimes we saw keywords, but because of the way, again, that we designed it and because of the power of Kendra, it actually, a lot of people were searching for kind of full statements and kind of full questions that they were asking of it, which again meant the quality of the results were much more powerful as well. So where would we go next? I think what we found is that this is an incredibly powerful tool to provide people the information that they need at their fingertips to be able to kind of find. And this combination of, our Factiva database, the Wall Street Journal's reach with the technology that's provided by AWS in the form of Kendra made it a very, very kind of easy to develop an intuitive experience for our end customers to be able to use. And actually internally, we've been thinking a lot about, well, where else could this be applied? Obviously, elections is an every 4-year or every 2-year cycle, and we kind of think there's applicability, maybe not at the same scale, on CEO speeches, earnings report, other kind of things that our readers come to us to go deeper on. We definitely think there's areas that we could have improved and working with AWS, for example, like this concept of the compound keyword. So one of the things that we saw was, what has Biden said about student loans, or what's Trump said about student loans, and the results would return a lot about what they said about loans in general, but not necessarily about student loans. And we have some ideas about how we can make that smarter and more helpful in terms of getting the right results. And I think the other thing about this kind of search versus browse thing is Kendra provides 100 or so results, and actually when you're searching and you're searching by a keyword or you're searching by a statement, that makes total sense. But for browsing, actually what we want to be able to do in the future is actually increase the amount of results that we're able to kind of provide. But overall, I mean, in terms of the speed that this idea went from being kind of an internal tool, being re-architected for hundreds of thousands of people to come to it and be able to use it, which is then what we saw. It was incredible how quickly we were able to do it and how effective the experience was in terms of the user engagement. So with that, I'd like to hand back over to Sherry.
So thank you, Raman, for sharing that insightful journey of how Wall Street Journal used Kendra and natural language search for Talk 2020. The best use cases are always the ones that are real use cases directly from our customers. So we appreciate that. So in closing, for those of you that are interested in learning more about natural language search and Amazon Kendra in particular, I've highlighted here some helpful reference links to get you started. So thank you all for joining. We appreciate your time. Have a nice day.